Good morning, children. Let us start with derivatives of implicit function. Now let us see what you mean by implicit function. Suppose, children, if I have a function of the type x plus y equal to 5. Okay. Now if you see this example, children, here you can see that I can write y in terms of x, or I can write x in terms of y. Because x and y are free variables, it can be very easily shifted to my left or my right, and I can find the value of unknown y or unknown x. So such functions are called as explicit function. That means one can be written in terms of the other. That means y is equal to f of x form. Now look at this example, children. It is x plus y is equal to sin y. Now here, however hard I try, children, I will not be able to write y in terms of x alone. Can I write? No, because this y, if I keep it on my left side, even after this x goes here, this y is not in terms of completely f of x. It is again having sin of y, and from sin of y, the trigonometric function sin cannot be removed from it. Exactly, because sin of that angle y you are looking. So I cannot remove sin from this y. Okay, so here I am not able to write x exclusively in terms of y or y exclusively in terms of x. So such a function is called as implicit function of x. That means y here cannot be expressed as an explicit function of x. Okay, even though x can be written, but y cannot be written as explicit. So it should be both ways. So such function is called as an implicit function of x. Okay, so we are going to learn how to find derivatives of implicit function. So how is the rule here? To find dy by dx of implicit functions, differentiate on both the sides of the implicit function with respect to x. Take all the terms involving dy by dx to one side and the remaining to other side. Solve for dy by dx. Okay, this is the working rule. We will do it. They are saying that you have to take all the terms involving dy by dx on one side after taking its derivative, and the remaining terms to the other side. Then you have to solve for dy by dx. Okay, this will be clearly understood after we are going to solve problems on it. Okay, when we solve problems on this exercise, I will explain you better. So that was derivative of implicit function. Now let us learn how to find derivative of inverse trigonometric functions. We have ready-made formulas. Excuse me. We have ready-made formulas as we had for trigonometric function. So let us derive one by one. So we want to find derivative of sin inverse of x. So let us take y as sin inverse of x. If I take sin inverse of x, because sin inverse is existing, I can very well take sin y. Okay, I can write sin y because sin inverse can be taken to your left side. So this will be sin equal to x. Now you differentiate with respect to x. So what will you get? Differentiate with respect to x. Okay, so it will be sin y's derivative will be cos y, but it is y, not in x. So we have to take derivative of it also. So this will be cos y dy by dx equal to 1. So this is dy by dx is 1 by cos y. Now you know that sin square y plus cos square y is equal to 1. So if you shift the terms, you have cos square y is equal to 1 minus sin square y. So cos y will be equal to square root of 1 minus sin square y. But sin y is what? X. So it is 1 upon square root of 1 minus x square. So for all values of x between minus 1 to 1, your function will be defined. Because if it becomes minus 1 or 1, it will become 0 and it will not exist. So I have restricted to open interval minus 1 to 1. Okay, so derivative of sin inverse of x is 1 upon square root of 1 minus x square. Okay, in this range. Now same way let us find for cos inverse of x. We have already learned, children, sin inverse of x plus cos inverse of x is pi by 2. Yes or no? So if I take derivative, what will happen? D by dx of sin inverse of x plus d by dx of cos inverse of x will be d by dx of pi by 2. But constant function, it is 0. Sin inverse of x derivative we have already found out. It is 1 upon square root of 1 minus x square. So in the next time, if I shift it here, d by dx of cos inverse of x is going to be minus 1 upon square root of 1 minus x square. Okay, so this is the derivative. Now tan inverse. Okay, so tan inverse of x, same way, let y equal to tan inverse of x. So tan of y will be equal to x. Now differentiate with respect to x. So it will be tan's derivative is sec square y. Y is not in the standard form. So chain rule, no? attach dy by dx equal to 1. So dy by dx will be equal to 1 upon sec square y. Okay, but sec square y is what? 1 plus tan square y. So this is x square. Okay, so d by dx of tan inverse of x is 1 upon 1 plus x square. Now derivative of cot inverse of x. Okay, so it is y equal to cot inverse of x. So we know that cot inverse of x plus tan inverse of x is pi by 2. So they will have a difference of minus sign. Okay, just look here. So they have a difference of minus sign. Pi by 2 will become 0. D by dx of cot inverse of x will be minus 1 upon 1 plus x square. Okay. The next one is sec inverse of x. Okay, sec inverse of x same way. Y equal to sec inverse of x. So sec y is equal to x. Differentiate with respect to x. So it is sec y tan y dy by dx is equal to 1. So dy by dx is 1 upon sec y tan y. Tan y is square root of, now you know that sec square y is equal to 1 plus tan square y, right? So tan square y will be equal to square root of sec square y minus 1. So this is x into x square minus 1. Okay. Again, x should not be taking the values minus 1 to 1. Okay. X should not belong to this range. So this is true. Similarly, you know that sec inverse of x plus cosec inverse of x is pi by 2, right? So this will be minus 1 upon x into square root of x square minus 1 square. So this is your derivative of sec inverse of x. So I have solved problems on it. Now this is the table for inverse trigonometric functions and its domain. Okay, so sine inverse of x derivative is 1 upon square root of 1 minus x square. So whatever we have found out, I have tabulated it here. Okay, now these are the domain of f dash of x. Okay, otherwise your denominator will become 0 and it will not exist. Okay, so if it is, or if it takes value minus 1, it will be 0. If it takes value 1, it will become 0. So that's why we have removed all the problematic points. Okay. So that's all for today. Next time, children, we will solve problems based on it. Then you will understand better how to use it. Thank you, children.